Welcome back to the channel, people. We've got a T-Mobile network update for you, courtesy of a buddy of mine. Shout out to Speed Tech. ATL, he's always stumbling upon some pretty cool finds, network updates and builds from T-Mobile that are atypical to what I think a lot of people see in different markets. You know, Atlanta's got a high usage, rate for T-Mobile. They got a lot of customers, probably some pretty high market share, and just, very demanding usage patterns from the customer base. So because of that, you get some pretty cool network builds and some cool elements to enhance the network experience that you wouldn't see in other places. So I'm going to start here showing you guys kind of the setting. He stumbled upon some mmWave from T-Mobile. I know a lot of people have the perception it's not really something T-Mobile's focusing on. It's not really something they're good at or want to do, but they do utilize it. Just seems they're really picky about where they put it. And Atlanta seems like one of the places where the engineering team seems to spend some money and put some of their budget into the really amazing technologies. So I can't really zoom in anymore, but in this particular image, you'll see that the setting here, it's kind of like a multi-dwelling unit. You've got what appears to be some sort of an apartment complex, and it's at a pretty good height. I'd say that's at least 100 feet, probably a little tall. I mean, these trees got to be at least 30 feet tall. So it's pretty tall. And then you can kind of see the placement, and I think I can zoom in for you guys with a different image. Yep, here you go. So for those of you that haven't really been able to discern the different types of, radios and antennas, this one on the left, the larger one, that's going to do all of your frequencies that are not considered to be the high capacity ones. So that's going to be all of your low band. That antenna is going to also do some of the lower mid band frequencies too. So like this is doing the 600, the low band, it's doing the 700 if they're broadcasting it there. It's also going to do your PCS, your 1900, and then your AWS, which is 17 and 2100. But the one that's in the middle, that I guess we'll call it the larger square, not really rectangular as much. That one's N41 specifically. It's probably a massive MIMO radio connected to it. I'm not sure if it's the Air, which is integrated radio and antennas. This one on the left, it's going to have all the radios separate. But you'll see that you got the mmWave joint, this little square one here, that's off to the right. All right, so that's cool. You can kind of see they anchored it up to give it a little bit of height. And then here's kind of some of the I guess the details of the connection. So here's the speed test from it. See, the ping time's kind of high. I'm not really sure what the reason is there, but 1.8 gigs down and 155 megabits per second up. You may see faster speeds from Verizon, probably like 3x that speed sometimes, like 2x, 3x. Verizon's just better at mmWave. It's something they've invested more time and resources into. I think Verizon also broadcasts more bandwidth with N260, the 39 gigahertz. You'll see here, you can kind of see how they do this connection. It's NSA 5G. And the way you know is you'll see the LTE anchor band here is band 66. You'll see the RSRP. That's decent, minus 91 for a mmWave connection. And I think this is a pretty solid connection here. So the SA is probably going to be all like the N41 and stuff like that. But the NSA is what's required for their mmWave applications, because I don't think they're paying Ericsson for the access to the NRDC, where you combine the mid-band 5G with the mmWave 5G, like what you see with Verizon. Here's another kind of showing of it. The first connection I showed you was N257. Here's N258 from a different location, I think. So they're building mmWave pretty good. For those of you, and here's that connection, you'll see it's a little bit different. And I think it's because of the bandwidth. 1.1 gigs down and 162 up. And, like this particular mmWave connection, I don't know, N257 is kind of like, I don't know, the frequency technically is from like 26.5 gigahertz to 29.5, but I guess it's basically the same as N261, I think, which is like technically 20 gigahertz as well. I just think it's somewhere in that range. I'm not sure, why they gave it a different band number. It just, when I look at the spectrum licenses for T-Mobile, they have like, looks like about 400 megahertz of bandwidth. That might be why we're not seeing the Verizon speed, where they're showing us like 4 and 5 gigabits per second. I think Verizon's broadcasting like 800 megahertz. That might basically be it, right? And now that Verizon is using NRDC with mmWave and C-band together, makes it a more dynamic connection, gives it some stability. It helps the uplink be stronger and more resilient. I think it's about time that T-Mobile took that step. We didn't see them utilize that in Vegas for the F1 races while Verizon was. I think if T-Mobile is going to be the 5G leader, how about you use some of the leading 5G technologies pay the cost, get access to those patents and licenses, and just do it right. But I'm nitpicking. Yeah, you know me, I'm a stickler for the technicals sometimes, but yeah, this is really good to see. Again, another situation where, you know, Verizon does some incredible things, but T-Mobile's utilizing some of these things too. They're just more selective about it, and I think doing it in specific locations, just kind of cherry picking their spots. Anyways, tell me what you guys think about this. What are you seeing from T-Mobile? Are they doing some of this where you are? If so, share with me. You know, which markets are you in? Because this is Atlanta, and this is good to see. Thanks for watching. Like, share, subscribe, drop us some comments, check out some more of our videos. We'll see you guys on the next one.